Okay, we are back with some quick math. Before we get into the example, I think this will be the last video as a summary or introduction. Before we get into the example, we need to discuss negative angles. Okay, we haven't spoken about negative angles yet. So we'll do this video and then we should be ready for any questions, any examples, or any exam questions that we could find. Like the video, subscribe to the channel, share the content with anyone doing pure math, technical math, grade 10, grade 11, and grade 12 level. Okay, drop a comment if there's something you didn't understand or need me to re-explain, or something that you want me to do content on that I maybe haven't covered yet. Okay, let's get into the video. So there we have a Cartesian plane. I'm going to make CAST again, cost CAST. Right, that's always valid. And when we speak about theta, theta is an acute angle, so smaller than 90. Okay, so maybe like 30 or something. If I draw theta in my like let's say theta is 30. If I draw 30 in my Cartesian plane, 30 would be over here, right? So we would say 30 is there. Okay, but for the purposes of this video, we want to talk about a negative 30, so a negative angle. So we want to be able to reduce sine of negative theta, okay, and figure out what that is. So you can't actually get a negative angle. You can't actually get a negative distance either, right? So if I say you go minus 5 meters, you can't really go minus 5 meters, but I can say that you go 5 meters in a different direction. Similarly with our angles, you can't have a negative angle. The negative simply tells us that we are moving in a different direction. Okay, so instead of going anti-clockwise like we have this 30 over here, if I say minus 30, I'm going to be going clockwise. I'm going the other direction. So if I were to draw minus 30, that would put me over here. So this would be a minus 30. So simply we are going 30 degrees in the opposite direction. So how do we reduce a negative angle? Okay, let's go back here. We again always start inside our bracket. So inside we have a negative, and now I'm saying negative acute, so minus 30. Where does that put me? Which quadrant does that put me? That puts me in this fourth quadrant, and cos is positive there. I have sine. Sine is negative in that quadrant, so this reduces to minus sine of theta. Okay, we could also then have cos of our negative angle. Okay, so again, we say negative theta. Where does that put you? Negative puts you over here, negative acute. Cos is positive there, right? So I'm dealing with cos, and cos is positive there. So this reduces to positive cos of theta. And then also we could have tan of negative theta. Again, which quadrant? Negative, negative puts you in this quadrant. Okay, cos is positive there. I'm dealing with tan. Tan is negative in that quadrant, so this is going to reduce to negative tan of theta. Okay, one more thing. I think before we get to our example, and this was only 3 minutes, so we can maybe discuss one more thing. Whenever we've dealt with reductions so far, right, the previous two videos that we've covered, we maybe had something like this, 180 degrees minus theta, okay, where our 180 was first and then our theta was second, right? So what do we do when it's the other way around? Let's say you have something like this, theta minus 180 degrees. Yeah, so I'm going to show you two ways to deal with this, because at times you might want to do the long method, and then I'm going to show you a shortcut, which I'm not super keen on, but you can also go with a shortcut, right? So the long method is going to be like this. You are going to say sine, and you are going to take a negative out as a common factor. So if a negative is taken out as a common factor, when you take out a common factor, what do you actually do? You divide everything with your factor. So if I take out a negative, right, so inside now, this theta is going to be a negative theta, and that minus 180 is now going to become a plus 180. So all I did was I took out negative as a common factor. So here I now have sine this negative angle. What is this angle? That is 180. That's positive, minus my theta. And well, let's make that a square bracket just for consistency's sake. All right. So now this looks exactly like I want this over here. All right. But this is a minus in front of a bracket, so I'm confused again. But let's remember the reduction. So in fact, let's replace this with something else, alpha. So now what I have is I actually have sine of minus alpha. Okay, so sine of a negative angle, right? Sine of a negative angle, we go up here. Sine of a negative angle, it reduces to minus sine of that angle, but we didn't actually have an alpha. So let's just go back and say it's minus sine of our 180 degrees minus alpha, well, theta. 180 minus, we should know that that's in this quadrant over here. That's 180 minus. So that is going to be positive. So this negative you see is still here. This part reduces to positive sine of theta. Okay, so there's my reduction. Okay, and a short way of doing maybe the same thing would be to do this, to think like this, right? Sine of theta minus 180. So remember we said theta, let's get another random Cartesian plane up here. We said theta was an acute angle. So maybe theta is over here, that's theta. And if I say 180 minus that, where is it going to put me? So there's 180 and I'm subtracting, so I'm going to go that direction. So 180 minus is going to put me over here. Okay, so now I'm going to say, okay, sine, positive or negative in this quadrant, it's going to be negative sine of our theta, which is what we see that we got over there. So this also works, okay? I do prefer that you know and understand all of this. The more complete understanding is going to help us further in the future, but this is going to be our shortcut. All right, with all of that, I think we can finally get into our examples.